Ever wondered what shaped the genius mind of Sir Isaac Newton, one of the most influential scientists of all time? Our journey begins in the year 1643 in a small town in Lincolnshire, England, where Newton was born on Christmas Day. His start in life was far from easy. His father had passed away 3 months before his birth, and when he was just 3 years old, his mother remarried, leaving young Isaac in the care of his maternal grandmother. Despite these early challenges, Newton showed an extraordinary aptitude for learning. He attended King's School in Grantham, where he began to develop his scientific and mathematical prowess. But it wasn't until he was 18 that his life took a pivotal turn. In 1661, Newton entered Trinity College, Cambridge. Here, he immersed himself in the works of the great philosophers and mathematicians of the time. The college environment nurtured his inquisitive mind, providing the perfect setting for his intellectual growth. Newton's early years might have been marked by personal loss and hardship, but these experiences didn't hinder his progress. Instead, they fueled his determination and resilience. These were the formative years that honed his analytical skills, shaped his scientific curiosity, and laid the groundwork for his future groundbreaking discoveries. These early years were the foundation that shaped Newton's scientific mind, setting him on the path to greatness. How did Newton's time at Cambridge shape his scientific trajectory? Let's delve into this pivotal chapter of Newton's life. Isaac Newton enrolled in Trinity College, Cambridge, in 1661. As a student, his primary focus was on the traditional curriculum of Aristotelian philosophy. However, Newton's passion lay in the emerging fields of mathematics and physics, and he quickly immersed himself in the works of modern philosophers such as René Descartes and astronomers like Galileo Galilei. This was a time when the scientific revolution was reshaping the way we understood the world. And Newton, with his insatiable curiosity, was right at the heart of it. He began to develop his mathematical methods, laying the groundwork for what would later become calculus, a branch of mathematics that has since become fundamental in physics and engineering. But Newton's interests weren't limited to numbers and equations. He was equally fascinated by the nature of light. He conducted several experiments dissecting sunlight with a prism and discovering that white light is composed of a spectrum of colors. This early work on optics would later lead to his development of the reflecting telescope, revolutionizing astronomy. And then, in 1665, the Great Plague hit England. Cambridge University closed its doors and Newton was forced to return to his family home in Woolsthorpe. This could have been a setback. Instead, it turned out to be a period of intense and fruitful scientific inquiry for Newton. Away from the university, he had the freedom to delve deeper into his own ideas. It was during this time that he formulated his laws of motion and universal gravitation. So, as we can see, Newton's time at Cambridge was a period of intense study and groundbreaking discoveries, shaping his scientific trajectory in profound ways. It offered him the intellectual stimulation of the academic environment and the solitude to reflect and develop his own theories. And when faced with adversity, Newton turned it into an opportunity for scientific exploration. It was during this period that Newton laid the groundwork for his most significant discoveries. What groundbreaking discoveries did Newton make that changed our understanding of the universe? Isaac Newton, a name that resonates with scientific revolution, made 3 major discoveries that have shaped our understanding of the world and the universe at large. First, let's delve into his laws of motion. Newton's laws of motion, which he formulated in the 17th century, include 3 fundamental principles. The first law, often known as the law of inertia, suggests that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. The second law establishes that the force acting on an object is equal to its mass times its acceleration. Lastly, the third law states that for every action, there is an equal and opposite reaction. These laws are the foundation of classical mechanics, and they govern the motion of objects we see around us every day. Next, we move to Newton's discovery of gravity. While the story of an apple falling on his head might be more of a myth, Newton's formulation of the law of universal gravitation was indeed a monumental achievement. He proposed that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. This law explained not just why apples fall to the ground, but also how the planets revolve around the sun. Finally, we come to Newton's work on optics. He built the first practical reflecting telescope and developed a theory of color based on the observation that a prism decomposes white light into the many colors of the visible spectrum. His studies paved the way for the field of spectroscopy. Each of these discoveries in their own right was groundbreaking. They have influenced centuries of scientific thought, providing the framework for our understanding of the physical world. These discoveries have had a profound impact, shaping our understanding of the physical world. What happened in Newton's later life, and what is his enduring legacy, you might ask? Well, let's delve into it. After his groundbreaking discoveries, Isaac Newton didn't simply rest on his laurels. He continued to be a powerful force in the scientific world and beyond. He took on important roles, including serving as a member of Parliament and taking the reins as the warden and master of the Royal Mint. In these roles, he brought the same rigor and determination that he had applied to his scientific work. He even helped to restructure the British currency system. In 1705, Newton's contributions to science and to his country were recognized with a knighthood. From then on, he was known as Sir Isaac Newton. Newton lived a long and impactful life. He passed away in 1727, leaving behind a legacy that continues to shape our understanding of the world today. His work laid the foundation for generations of scientists who came after him. His laws of motion and universal gravitation, his work on light and color, his mathematical contributions, all of these have had a profound influence on fields from physics to astronomy, from engineering to space exploration. Newton's ideas have even permeated into our everyday lives. Every time we watch an apple fall from a tree or feel the pull of gravity keeping us grounded, or see a rainbow arching across the sky, we are witnessing the principles that Newton helped to illuminate. His legacy extends beyond his scientific achievements. Newton's approach to inquiry and discovery, his relentless pursuit of understanding, his ability to see beyond the surface and uncover the underlying principles governing the world around us, these have all become a part of the scientific ethos. Sir Isaac Newton's legacy continues to inspire and influence even centuries after his death. His life, his work, his curiosity, and his dedication to uncovering the truths of our universe are a testament to the power of the human mind to explore, to understand, and to innovate. And that's something worth remembering. So, why do we remember Isaac Newton today? Born into a farming family in Lincolnshire, England, Newton's early life was far from ordinary. He was not interested in running the family farm, but rather he was captivated by the mysteries of the natural world. This curiosity led him to Cambridge University, where his fascination with mathematics and physics blossomed. At Cambridge, Newton made his mark. He developed the binomial theorem, explored the nature of white light, and laid the foundations for calculus. However, his most significant work came during a plague-induced isolation, when an apple falling from a tree sparked the idea of gravity. Newton's groundbreaking discoveries didn't stop at gravity. He formulated the three laws of motion, which are still fundamental in physics today. He also made significant strides in optics, demonstrating that white light is composed of a spectrum of colors. In his later life, Newton held high-profile positions, including serving as the president of the Royal Society and the warden of the Royal Mint. Despite his achievements, he remained humble, once remarking, "I do not know what I may appear to the world, but to myself, I seem to have been only like a boy playing on the seashore, and diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary." Truly, Sir Isaac Newton's life and work have had a profound impact on our world, changing the way we understand the universe.